Real numbers. Part 4. Okay, moving on to our exercise section. That is which is the last exercise in this chapter 1.4. The first question. Without actually performing the long division, state whether the following rational numbers will have a terminating decimal expansion or a non-terminating repeating decimal expansion. Okay. So we have the 10 numbers here. So what we have to prove? We have to prove it has a non-terminating or terminating decimal expansion. Okay, without performing long division. So without performing the actual division, you have to prove this. How we can prove this? By using our three theorem. Okay, we have studied three theorem connecting this. By using that three theorems, we can determine by looking the prime factorization of denominator whether it terminates or not. Okay. One more question is that write down the decimal expansion of those rational numbers above which have a terminating decimal expansion. So if terminates, we have to write what is its decimal expansion. So what is our method? At first we have to find prime factorization of Q and to check whether it has only 2's and 5's. If it has only 2's and 5's, then it has a terminating decimal expansion, otherwise non-terminating. Okay. Then our first question, 13 by 3125. So what is 3125? It is 5 raised to 5. Okay, which is equal to 2 raised to 0 into 5 raised to 5. So it has a terminating decimal expansion. Then what about next? If it has a terminating decimal expansion, we have to find what is that. In order to get that, we have the denominator contain only 5 raised to 5. So what we have to multiply which numerator and denominator? We have to get 10 in the denominator. So we have to multiply it by 2 raised to 5. So 13 by 3125 equal to 13 into 13 by 5 raised to 5, which have to multiply by 2 raised to 5. Then we will get 416, that is 13 into 32 divided by 10 raised to 5. That is, we need a 10 and 5 decimal places here. So 416, here we put 2 zeros, that is 0.00416. Is it the terminating decimal expansion? Then what about 17 by 8? 8 equal to 2 cube, which is of the form 2 raised to n into 5 raised to n. Okay, so it has also terminating decimal expansion. So we have to find that. So in order to find what we have to do, we have to multiply each term by 5 cube. So 17 by 8, 5 cube, 5 cube. Then we will get 2125 by 10 cube, which is equal to 2.125. It is its decimal terminating expansion. So why we are multiplying it 5 cube? In order to get 10 cube as our denominator. That is some multiple of 10 as our denominator. Here we already have 2 cubes, so we have to multiply it by 5 cube. Then what about next? 455 is something different. So what is that? 455 equal to 5 into 13 into 7. How we can find this? By using our previous techniques. Okay. What is that? How to find it is divisible by 7 or not? Okay. Oh, it is divisible by 5. Then we will get one number. So to check a divisible by 7, what we have to do? We have to multiply 5 by 2 and we have to subtract it from 45. What is that? 35. 35 is divisible by 7. Okay. Similarly, we can approach the test of 13. What is that? We have to multiply this by which number? Nine. Okay. 5 into 9, 45. 45 minus 45, it will give 0. For further information, check description. Okay. Then over 55 equal to 5 into 30 into 7. What is the test for 30? We have to multiply last digit by 9 and we have to subtract it from other two digits. Okay. That is 5 into 9 45. 45 minus 45 will give 0. So it is divisible by 30. So our decimal expansion is 5 into 30 into 7. So it has it has something different from not decimal expansion, prime factorization. So its prime factorization is something different from 2 raised to n into 5 raised to n. So we have a non-terminating decimal expansion. Okay, what about the next 15 by 1600? Okay, here one problem was that is 1600 equal to 2 raised to 6 into 5 raised to 5 square. Whether it has a terminating decimal expansion or not. Here 15 and 1600 has a common factor other than 1, that is 5. So we have to check by cancelling 5 from each term. We will get that 3 by 325. 3 by 325 has a HCF 1 and that 325 as a prime factorization 2 raised to 5 into 2 raised to 6 into 5. So it has a terminating decimal expansion. So we have to find the term expansion. Sorry, 320 here, for not 325, 320. Then in order to get a decimal expansion, we have 320 equal to 2 raised to 6 into 5. Then on multiplying, we have to get 5 raised to 6 here. So we are multiplying it by 5 raised to 5. We will get 3 into 3125 by 10 raised to 6, which is 9375 by 10 raised to 6, which is equal to 0.009375. So that we need 6 decimal point here. So these numbers after decimal point here. Then next 29 by 343. 343 equal to 7 into 7 into 7. Okay, it is something different from the prime factorization is something different from 2 raised to n into 5 raised to n. So its decimal expansion is non-terminating recurring. Okay, that is okay. Then about our sixth question, 23 by 2 cube into 5 square. This is our sixth question. It has a terminated decimal expansion. Why? It has on denominator has only prime factorization. Denominator prime factorization is only 2 cube and 5 square. That is, it is of the form 2 raised to n into 5 raised to n. So it has a terminated decimal expansion. Find what is that? We have to multiply numerator and denominator by. Here we have 2 cube. Here we need some 5 cube. So we have to multiply each term by 5. Okay, numerator and denominator by 5. On multiplying by 5, what we will get? 115 by 10 cube, which is equal to 0.115. Then our next question, 129 by 2 square into 5 raised to 7 into 7 raised to 5. It has a non-terminating decimal expansion. Why? It has a number 7 raised to 5 here. Okay. So, non-terminating decimal expansion because the prime factorization has other factors than 2 and 5. So, for decimal expansion, prime factorization has some numbers other than 2 and 5. That is 7 raised to 5 here. That is, it has some prime factor 7 here. So, it is non-terminating. Then what about next? 6 by 15. It is simple. That is 15 equal to 5 into 3. It has something different from our usual decimal expansion. That is 2 raised to n into 5 raised to m. That is, it has other prime factor 3. So, the decimal expansion prime factorization, it has the prime factorization 5 into 3. It is not of the form 2 raised to n into 5 raised to m. So, it has a non-terminating decimal expansion. Okay, that's okay. Next question. 35 by 50. 50 equal to 2 into 5 square. So whether it has a terminating decimal expansion or not, for that we have to cancel the common multiple between common terms between 35 and 50. That is, we will get 7 by 10. 7 by 10 HCF is 1. So it has only prime factors as 2 and 5 in the denominator. So it has a terminating decimal expansion. Then what is that expansion? 0.7. Okay. Then about 10th question. 77 by 200. It is clearly, it has other terms in the prime factorization other than 2 and 5, that is 7 and 3. So it has a non-terminating decimal expansion. Note, since it is a rational number, every term has a decimal expansion which is non-terminating and recurring. You have to note that non-terminating, but they are recurring in their manner, since it is a rational number. So let us move on to last question of this exercise and this chapter. That is, the following real numbers have decimal expansion as given below. In each case, decide whether they are rational or not. If they are rational and of the form P by Q, what can you say about prime factors of Q? So what this question is about? So we have a set of numbers here, that is their decimal expansion is given below. What we have to do? We have to decide whether they are rational or not, that is rational or irrational. And if it is a rational number and of the form P by Q, we have to comment about what is the prime factorization of Q or the prime factors of Q. That's all. So, how to find a number is rational or irrational by having a look on its decimal expansion? It is by, we have studied earlier, if it has a decimal expansion which is terminating or non-terminating but recurring, then it is a rational number. That is, if the number have a decimal expansion that is terminating, that is stopping, or if it has a decimal expansion which is non-terminating but repeating, that is, it has to repeat infinitely, then it is a rational number. Okay, that is, if for example 0.333, 0.555 or 0.121212, 0.123, 123, 123, etc. They came into the category of rational number. What about irrational number? If it is non-terminating and non-recurring, that is, it is not terminating and it is also non-recurring, that is, it is non-repeating decimal expansion. If it is a non-repeating decimal expansion, then it is a irrational number. That is, non-terminating, non-repeating is a irrational number. So we have here 3 questions. And the first question is 43.123456789. It is a terminating decimal expansion. So it came into the category of rational numbers. Terminating decimal expansion, hence it is a rational number. Hence, what about the prime factorization of Q? That is, it is of the form 2 raised to n into 5 raised to m. So let us verify this. You can stop this from here, or either if you wish you can verify this. Okay, since it is some fact that we have studied from the theorem, you can stop here. Or if you would like to verify this, you can move forward. That is, in order to write this in the decimal form, in the form P by Q, what we need to do? We have to multiply the numerator and denominator with the the multiples of 10. Okay, here we have 9 numbers after the decimal point. So we have to multiply the numerator and denominator by 10 raised to 9. Okay, we are multiplying it by 10 raised to 9 and dividing it by 10 raised to 9. Then what we will get? 4, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9 by 10 raised to 9. This is the form of decimal expansion of the given number. Okay, then which has the HCF 1. Why? The 10 have only prime factors 2 and 5. 2 is not divisible in this number since it ends with the odd number. Okay, since it doesn't end with 0 or 5, what we can conclude? It is not a factor of 5. So these two numbers has HCF 1. Then what we can comment about Q? Q has only the prime factors 2 and 5 since it is 10 raised to 9. Okay. Then here Q equal to 10 raised to 9, which is equal to 2 raised to 9 into 5 raised to 9. Okay, Q has only prime factors 2 and 5. So we have verified this. Then what about our next question? Which is of the form 0.120, 1200, 12000, 12000. Then what will be the next term? 1, 2 and 5 zeros. Okay. So it has a non-terminating decimal expansion. That is, it is not terminating at any point. And what about it is recurring or not? It is not recurring. Why? If it is recurring, something will be repeated. It is not repeating. Okay, if it is repeating, it will be 120, 120, etc. It is not like that. Its decimal expansion is increasing x0 at every point. Okay. So it is not repeating and also non-terminating. So what we can conclude? Non-terminating, non-recurring decimal expansion. Hence, it is an irrational number. Okay, that's all. Next, that is 43.123456789123456788. That is, it has a repeating decimal expansion here. That is, it is repeating infinitely, but it is not terminating. So we are representing it like that. That is 43.12345678. This bar will represent, that is, it is repeating infinitely. Then it is a rational number. Why? It is not terminating but repeating. So what we can conclude about the factors, prime factors of Q? Since it is non-terminating, the Q has other prime factors than 2 and 5. Why? If it has a prime factor, if it has some prime factors 2 and 5 only, then it terminates at some points. Okay. So it has other prime factors than 2 and 5. Hence, it is rational number since it has non-terminating and recurring decimal expansion. Since it is non-terminating, Q has a prime factors other than 2 and 5. And Q not equal to 2 raised to n into 5 raised to n. Maybe it has some other prime factors here or it is not on the form 2 raised to n into 5 raised to n. So you can stop this from here, and for your further information or more information, let us rewrite this number in the form of P by Q. This is something for more information. Okay, you can stop this. The question is over from this step. Then, so for that we are taking x equal to 43.12345678. So how many terms are after the decimal point? 9 points. Okay, then we have to multiply x with 10 raised to 9 and this also with 10 raised to 9, that is 1 and 9 zeros. Then what we will get? that is 10 raised to 9 into x, that is 1 and 9 zeros are here, equal to 43.123456789, and again 2345678. That is, if we multiply with the 10 raised to 9, we will get 43. That is, the decimal points are moved to left side. That is, 9 decimal points move to left side. Then 9 numbers after decimal point will move to left side. Then we will get 4312345678.123456789 bar. Okay. So what next is, we are subtracting 2 minus 1. Then we will get, that is 9 x equal to 43123456746. How this came? Or subtracting this from this 1 2 3 4 5 6 7 8 9 and 1 2 3 4 5 6 7 8 9, that is the points after decimal point will become 0. Then here we have 9, here we have 3, so 6, here we have 8, here we have 4, 8 minus 4, so we get 999 x equal to 431234566746. Then what about x? X equal to 431234566746 divided by 999. Okay, by cancelling the common terms, we will get, that is 9 is common in both, we will cancel them each other and we will get 4791495194 divided by 1111111. This is the 4x in the p by q. That is, the x is transformed into p by q form. What is our x? 43.123456789 bar. So, the p by q form, that is the rational form of 43.1236789 bar, equal to 4791495194 divided by 1111111. This is something you have studied in your life standard. For further information, I have given this here. Okay, thank you. Our chapter is over.